Hi, physics. This is Mr. Janowski. This is chapter 32, homework 2, and I'll just do problem 1 here. So what's going on here? For problems 1 through 3, write the given vectors in angle notation. So what are we doing here? What are we looking for, and what do we expect it to have? We want this stuff in angle notation, which means if we're going to do problem 1, we want f sub a is equal to, hopefully you can see that that's an equal to, f sub a is equal to, so angle notation will be the magnitude of the vector, and then this indicates the angle, and then the angle in degrees, and all this will be newtons. Now you will also, it might make more sense to have written this way, question mark newtons at an angle, but I'm just going to be consistent, do it the first way. All right, so what are we doing here? Basically, we have to do a step 0. A lot of this chapter will be step 0. If you remember back from last year, what is step 0? Step 0 is you're playing with the vectors and you're dealing with the components and things like that. So for problem 1, what do we have? 30 I hat plus 40 j hat newtons. Okay, so let's start with some kind of Cartesian plane. So this guy is going 30 I hat. So I try to draw that right over there. So let's say that f sub a sub x, it's 30 newtons in that direction. F sub a sub y is going to be 40 newtons in this direction. So I try to draw it so it's just a little bit bigger. So F sub a sub y is equal to 40 newtons. And the thing we're actually looking for is going to be this one. This is F sub a. So this is the thing for which we need to know the magnitude and the angle. So let me figure out this angle in here. Let's call it theta. That seems like a good name for an angle. Okay, so how do we get this? First of all, Pythagorean theorem, a squared plus b squared is equal to c squared. Okay, so a, let's call this guy down here a. 30 newtons squared plus, let's call this one b. 40 newtons squared. This has to equal the hypotenuse, which is f sub a squared. So if you do all that in your calculator, what do you get? You get 30x squared plus 40x squared. You get a pretty big number. 2,500 newtons squared. Okay, but we don't want f sub a. We want the square root of that. So you get to take the square root of that number. And I picked this so that it would be a 3, 4, 5 triangle, which means we're going to end up with f sub a has a magnitude of 50 newtons. So that'll be part of our answer. So let's circle that. The other thing we need to figure out is what is this angle theta? So at this point, I know all 3 sides. So I can do any kind of inverse trig to get to this angle. But I think it's a good idea to just always stick with tangent when you're doing these things. So remember that tangent theta will equal the opposite over the adjacent. So what is the opposite from this angle? It's this one. 40 newtons over the adjacent is going to be this one. 30 newtons. So what this means is that inverse tangent of 40 over 30, and the Newton part will just cancel, will give you theta. So if you ask your calculator how to do this, inverse tangent, 40 divided by 30, you get 53.1 degrees. So obviously very important that you have your calculator in degree mode for doing this. Okay, so we have both parts of this. So what does that mean? That means that if we're going to write this in angle notation, f sub a is equal to 50 at 53.1 degrees newtons. So there you have that. Do a quick step. We solved for the right thing. We gave it the right units, newtons and degrees. You have to have degrees. That is part of the units. So give it a check. So there's that one. Let me just quickly go on, rather than making two separate videos. Let's go on and do one of these harder ones. 4 would be in quadrant 1. Let's do 5 for this one. So if we're going to do 5, we're going to do 5. Step, write the given vectors in unit vector notation. So we're starting with the thing in angle notation. We want it in unit vector notation, which means the whole business with the I hats and the j hats. So for 5, we're looking for F sub E, force of Ernie or Elise. I don't remember who E is. So F sub E is equal to, it'll look something like this. Question mark I hat, this is this funny new notation that you're just learning, plus question mark j hat, newtons. So this will be the x component, this will be the y component of the thing. So how do we actually get there? Start again with a little Cartesian plane here. And let's figure out the angle first. The angle is 135. When you're doing these, you always measure from the positive x-axis and you go counterclockwise. So 135 from here is going to send us off in this direction. So how will I say this? So watch this. This time I'm going to call this one phi instead of theta. There's actually going to be two little angles we need to worry about. I'm calling this one phi. So this phi is 135 degrees. So what does that make this angle in here? Theta. Okay. Theta is going to be 180 minus 135 degrees. So theta in here is going to end up being 45 degrees. So hopefully you can see that's a 45. Okay. So there are different ways to handle this. I'm going to try to be consistent and always do it a certain way. So my way of doing this is I always think of my triangles as having positive sides, and I'm always going to make the interior angle be some kind of positive number like this. So yeah, you can do it a certain way with the calculator and actually just use the 135 number. But I like my step 0. Oh, I forgot to even label this. Yep, so this is step 0. Boop. So what do we have? F sub E, so that would be the hypotenuse here. F sub E is 225 newtons. And what I need to figure out are F sub E sub x and F sub E sub y. So how can I get those? I've got to do my step 0 stuff here. All right, so I'm going to use trig. So I know this angle, I know the hypotenuse, and I need to figure out both the adjacent side and the opposite side. I usually do sine first. Maybe I should do cosine. I'll do sine first. Okay, so remember what sine is equal to. Sine of theta is equal to opposite over hypotenuse. Remember with trig, so ka toa. Okay, so sine of theta is opposite over hypotenuse. Well, that means that opposite, so that's an O for opposite, not a 0, is equal to h times sine theta. So what does that mean in terms of the triangle we have here? Our opposite is f sub e sub y. So f sub b sub y is going to equal the hypotenuse. The hypotenuse is f sub e. So I'll just go right ahead and do the numbers. 225 newtons times sine of theta. And the angle we're dealing with is 45. So ask your calculator, what is 225 times sine of 45? And you will get 159.1. Which is more sig figs than I'm really supposed to keep here, but we're going to go with it. So 159.1 newtons. And this is up. You can see this component is going up. So let's remember that. That's going to be part of our answer. F sub E sub Y. Might as well color code this. Okay, so now we've got to get this other one. So you could use Pythagoras at this point if you wanted to. We now know two of the sides. You could use Pythagoras to get the third. But I try to be consistent, so I'm going to say cosine of theta is equal to adjacent over hypotenuse. So that means the adjacent is equal to the hypotenuse times cosine of theta. So what does that mean in this context? That means our adjacent is this guy, f sub e sub x. H is still going to be 225 newtons times cosine of 45 degrees. So ask your calculator, 225 newtons times cosine of 45, and it's going to tell you f sub e sub x is equal to 159.1 newtons. It's a 45, 45, 90 triangle. So that side will be the same as the other one. But notice something. F sub e sub x is going to the left. So that's going to be important. Don't know why I wrote that one in cursive, but I did. So that one's going left. So what does that mean? When we write our final answer, f sub e, it's going to be equal to the I hat part, which is 159.1 newtons left. So that's really minus 159.1 newtons plus 159.1 newtons up. So, you know what? I goofed. Let me grab the eraser. I should be more consistent. So that wasn't supposed to be an N for Newton. That should really be an I hat, and this should be a J hat. So there are our components, and all of this gets multiplied by the units of newtons. So now we have that one. So step, do we solve for the right thing? Do we write it the right way with the right notation? Do we give it the right units? Yeah, so minus 159.1 I hat plus 159.1 J hat in newtons, so that's all good. So we're happy with that. Hopefully you found that helpful.